Hi, Max. Hi, Max.
Okay.
How did you learn it?
For like the 20th time, sorry.
Wait, did you take the test?
Yeah, he did.
He did, and then he got the concussion.
All right, guys. So 4.2. So we are on page 3. Triangle angle sum theorem. Excuse me. So we had already talked about this, but I didn't really say it as a theorem. We didn't prove it yet. So what are the 3 angle measures add up to in a triangle? 180. Don't get that confused with the outside. The outside is perimeter. That could be anything greater than 0. So we know measure of angle A plus measure of angle B plus measure of angle C has to be 180 degrees. Now we're going to prove it. So why is that true? Think about any 3 sides that, any triangle that you create, whether it's acute, obtuse, right triangle, always the case. All 3 angles have to add up. Okay, so I'm going to walk you through. I already have the statements here. So what I need your help with is coming up with the reasons. Now, we're going to start out with a triangle. And one of the other things we're going to start out with we're going to say, make a line that goes parallel. That's actually a parallel postulate. I'm not going to worry about that part. But we have a triangle with these angles that I numbered just to make it a little easier, and 2 parallel lines. So you could basically do this with any triangle. You could take one side and make it parallel.
I don't think I got the name yet.
Last class. If you don't have one, there's an extra one in the green drawer, third one from the top. Okay, so let's talk about why would angle 4 and angle RPS be supplementary?
Definition of a linear pair.
Not definition of linear pair, but what's a linear pair? We're talking about angle 4 and this angle. They are a linear pair, but it's not definition of linear pair. Supplement theorem.
I didn't understand what the angle was.
The supplement theorem, which says if you have a linear pair, so this is kind of an abbreviated form, this implies that you have supplementary angles. Okay? Yeah, underneath there should be an angle. There should be a packet, not an angle. There's probably lots of angles in there too. Okay, next one. So going from statement 2 to statement 3. Boy, I'm stuck on the angles for some reason. Measure of angle 4 plus measure of angle RPS equals 180. Definition of supplementary angles. Does that make sense? When we go from saying they're supplementary to saying they're equal to 180, that's definition of supplementary angles. Okay.
That's the step that I missed.
All right, RPS, here's RPS, is equal to measure of angle 1 plus measure of angle 5. This was one we did way back in chapter 2. Angle addition postulate. Remember, what am I trying to do here? I'm trying to get angle 1 plus angle 2 plus angle 3 all equal to 180. So far, I know 4 plus these 2 have to equal 180. And I know, right, this whole angle equals 1 plus 5. So I want to try to see, look at angle 3 and angle 5. What kind of angles are those? Look at 2 and 4. Alternate interior. So if we can get these 2 equal and these 2 equal, could we get all 3 of these to equal 180? You see how we're getting that? Okay, so now.
Next one is substitution. Because you already have 2 statements that have it.
Yeah, no, this one is specifically substitution. So here's what I'm doing. I'm replacing this for this. So basically I'm saying measure of angle RPS, I'm replacing that with angle 1 plus angle 5. So this, I know it looks like a transitive, but this one is actually substitution only.
Oh wait, there's problems where you can only use substitution?
Yeah, there are some places where you're just replacing something with something else that it's equivalent to.
Transitive is statement.
Yeah, transitive you have to have like two parts, and then you put that together for the
So
third part.
basically, go to substitution and accept it as congruent.
Congruent uses transitive. That's a good one. Okay. Angle 4 is congruent to angle 2, and angle 5 is congruent to 3. We talked about
Alternate
this
interior angle
theorem. So I know you can write that out as the theorem name, or you could write parallel lines imply alternate interior angles. Bless you. Congruent.
Thank you.
Okay, we're almost there because if notice here I have an
Definition
angle
of
4
congruent.
plus angle 5 plus angle 1 equals 180. So if I can get these to be equal, then I can replace those
So
angles.
the next one's definition of congruent angles.
Mm-hmm. Does that make sense? We just went from congruent to equals. And now the last step,
Is the actual theorem.
the actuals, no, what is it? It's substitution. So I'm replacing, see here, angle 4, I'm replacing with angle 2. So it's angle 1 is going to stay there. Angle 5, right, is equal to angle 3. So it got replaced. So that's substitution. Did I prove angles 1, 2, and 3 add up to 180? Yes, so we just proved the triangle sum theorem. So again, it was a process of like angle addition and alternate interior angles. So we could apply that to any triangle out there and know that it always has to add up to 180. Okay, so let's use that theorem to just take a little break from the
Angle 2
proof.
is congruent to angle 1
Okay,
because
okay,
of
okay,
vertical
slow
angle
down,
theorem.
slow down. Okay, let's give everyone a chance to look at it first. So again, we're going to use that theorem. Now these are two separate triangles. They're not necessarily congruent. We'll talk about congruent triangles later. But we know vertical angles, angle 1 is congruent to angle 2. Well, what I would do is I would work with this bigger triangle first to figure out measure of angle 1. So take a minute to do that. Okay, just write it down. Don't call out to give everyone a chance to try. So we know these 3 angles have to add up to 180. And raise your hand if you have the answer for that. Paul? 70?
Oh,
They're both 70.
they're both measuring.
Oh, just measure of angle 1 is 70. Which makes, okay, so we get 70, which makes the angle 2 also 70. Right? Vertical angles are congruent, vertical angles theorem. Now I know 70 plus 68 plus the measure of angle 3 also has to add up to 180. So don't call out. Raise your hand when you have this, Sammy.
42.
We agree? 42. So sometimes when we have more than one triangle, like we would not have started with this triangle, the smaller triangle on the bottom right. We'd start with the one that we already know 2 of the angles and then go from there. All right. Take a look at the next picture. Which triangle would we start with? The top left or bottom right?
The
The
bottom
bottom
right. Bottom left.
You can start with angle 1.
Yeah, you could.
Just do 180 minus
You could start with that. That's fine. I'm just noticing that there's more than one way to find angle 3 in that case, just so you know. So here I know,
2 plus 71 plus 57.
yeah. Raise your hand if you have angle 2. Zachary?
It's what? It's 52.
52?
Yeah.
Okay.
And
Now.
29. And
Okay, angle 1
is
plus plus 57 is 180 because they form a linear pair. Raise your hand if you have angle 1. Maya, you have that? 123 sounds good. Now, with angle 3, there's actually 2 ways that we could do this. Because we have one big triangle, we could do angle 3 plus these 2 combined plus this one has to be 180. Or you could just do the small triangle, angle 1, which is 123 plus 28 plus angle 3. Either one will get you the same result. So we have angle 3 plus 123 plus 28. Raise your hand if you have measure of angle 3. Top. 29? Good. Okay, good with that? That's really pretty straightforward. So next what we want to look at, those are the interior angles. We want to compare that to exterior angles. What is an exterior angle? Okay, so the definition, it's basically an angle formed from one side of a triangle, and it's an extension of that other. So basically start from one angle and extend the side. That's all. Okay, so basically in a triangle, for each interior angle, we create one exterior angle. So imagine, so here, it kind of helps to think of this as going around. So like here's one exterior angle. So the next one.
You extend every line.
Okay, so I'm going to show you. So let's say we start here. This creates another exterior angle. We can extend it this direction. We get another exterior angle. So we don't want to start crisscrossing sides though. We just extend in one direction. That's kind of the key. You start from one side and extend it. Start from one side. We don't go like crisscross, so they're not crossing that way. Now, what do we notice about each of these, this exterior angle and the interior angle? They're always going to form a linear pair. So we have a linear pair here, here, and here. Okay, so our remote,
What is angle 1 from a linear pair to?
let me just, what is angle 1 from a linear pair? Just this angle. This is an interior angle here, but what I want to show you are the remote interior angles. Remote interior angles, okay? These are the interior angles which are not adjacent to the given exterior angle. So this one is adjacent, so this is not remote interior. These two, the ones that are further away, when you think of something like a remote island, right? Have you heard that word before to describe a remote island? Something far, far away. So when you have an exterior angle, we're thinking of the two that are far away from it, not adjacent.
Wait, you showed it.
Like another example?
Like, draw it out.
Like,
No, what I'm saying is, a remote interior angle is not confused what you're saying. That's a remote interior angle.
okay, for each exterior angle,
Right. There's one.
there are two remote interior angles. Here and here. What if I drew it this way?
Wait, is that the only exterior angle right there?
No, it's just,
Yeah, that's what I'm saying.
but,
So it depends on what you're talking about.
right, so Aiden, what I'm saying is the way that we define remote interior angles is defined specifically based on one exterior angle.
Oh, okay.
So remote interior angles come in pairs, just like alternate interior and corresponding and all of those. They come in pairs. So for each exterior angle, I can locate two remote interior. Now, could I have drawn lots of exterior? Like I could draw something like this. And I could extend each side.
Yeah, but now I see what you're
So here's A, B, C, D, E, F. So I could say, all right, what are the two remote interior angles to angle B?
saying. Oh, yeah,
D and F. What are the two remote interior angles to C? E and D. So for each exterior angle, I have two remote interior. But the reason they draw it, like they don't want to confuse you with drawing lots of different ones. But yeah, you could.
oh, yeah, now I see what you're saying. I was thinking that.
Yeah. Okay, so the last thing that we kind of, actually no, we have quite a bit and we're out of time. So exterior angle theorem, I'll just say this really quickly. The measure of an exterior angle is equal to the sum of the two remote interior angles. So for example, measure of angle DBC is equal to measure of angle A plus the measure of angle C.
I'm gonna do a screencast on
So, when do I see you guys again? Tomorrow?
Yeah. We need to rest this stuff